So welcome everyone to the third session of the data management in our module for the data management course. We're going to do the first part of the topic of relational data. So all of today's session is all about relational data. It's playing into sort of two parts, so there'll be a bit of a little break in the middle. So this first half is going to explore what exactly do we mean by relational data, and what advantages does it give us, and where should we be using it, and how sort of it can be structured. And then in the second part, we're going to look more at some of the ways in which we can use relational data. So in particular, we'll be looking at how we can use it to sort of summarize things from usually a low level of a sort of data hierarchy up to a higher one. And then also sort of a key part of relational data is being able to link these different data tables together. So I'll be looking at the different ways in which this can be done. So sort of our learning outcomes for today, especially the first half of this, is being able to explain what we mean by relational data, a little bit more technical, but also explain why it is important to use primary keys and or identifier variables within your data tables. This is very important when it comes to linking these data tables, and also have a little think about the different ways in which you can store relational data tables. So this kind of builds up on a little bit on a thing we had in a previous module, where we were sort of thinking about the differences between spreadsheets and databases. So we're just going to add a little bit more on to that towards the end of this first session. So what exactly is relational data? Now, if you were to look this up online in Google, I think you would find a lot of information regarding relational databases, which can often be quite technical, I find. You'll find lots of diagrams linking these different sort of summaries of data tables, and lots of arrows and lines and splitting off in different directions, trying to explain a relationship between all these different data tables and all these different keys within those data tables. And looking at it from that perspective, maybe if you're not a data scientist, but you're more of a data analyst, you might be a little bit confused by that, as this idea of relational databases definitely comes from a more technical data scientist background. But the principles are very much the same when it comes to a lot of our sort of data projects that are more about data collection and data analysis. And the base idea when we are thinking about relational data is these linking of these different tables in this same way as we saw in that database example. So we have data at these various levels, and we are storing these separately. But through these keys and unique ID fields, we can link these tables and data sets and merge certain information when it's necessary, and it kind of keeps everything neat and quite simple. So we don't have this one master data set with information that could be at the farm level, plot level, and plant level all in one place. I think we saw that on Monday with some of these examples of wide data, where it's keeping, say, the data at the farm level, and when it has these multiple plots, rather than putting one row per plot, what it was doing was having these groups of columns, the information about plot 1, and then a group that was information about plot 2, which is quite a messy way to put it. When it comes to relational data, rather than just simply switching that into a long format, we're also pulling out that plot information and putting it into its own separate table, but through these variables that we refer to as keys, which I'll explore a little bit more on the next slide, that we can link these tables together. So the information is always linked. It's never completely gone, and we can always refer back to be sure where information comes from. So an important part of relational data is these keys. And a key is a variable in your data set that uniquely identifies each row, or it uniquely identifies each unit within a certain variable. And these can be used to link these data sets together. And there's sort of two different types. What we have as a unique identifier, this is known as a primary key. So as you saw in the example in the YouTube video, is that you had this classes table and this had a class ID. Within that table, the class ID is the primary key. And then you had the students table and you had the student ID. So in that table, student ID is that primary key. Now, foreign keys, these are the main way we have in order to link different relational tables together. Generally, it is referring to the primary key of a separate data table. So this is where we get onto that enrollments table that was in the middle. That had its own primary key that he created towards the end of this enrollment ID. So that was uniquely identifying each row within the enrollments data set. But he also had student ID. And this is not a primary key in this case because it is not uniquely identifying each row. It's like uniquely identifying sort of each of a student unit within the table. So we saw that student ID can be replicated many times within that enrollment table because its primary job is to link up to the student table. And so it's through that we can make the link between those two tables. And this is what's known as a foreign key because it's basically the primary key from somewhere else. And the other case is that we had the class ID in that same table. So that was another example of the foreign key. And this was linking up to the class table as it was the primary key for the class table. So these keys are very important in keeping your data organized, keeping your data identifiable. And its key thing is that it is always able to link these different relational tables together. That's what's important about these key variables. So one of our projects recently at work has been this survey that is very long and has many repeat groups that has information at lots of different levels. And so because of these repeat groups from ODK that I explored in previous sessions, we end up with lots of different data sets across some spreadsheets in Excel. And as you'll see, there's actually quite a lot of them. I think it's nearly 30 or possibly above 30. And some of these levels might not be immediately obvious. So we have this main survey table where everything's at this one level of the household. But then, so we have the household roster, as somebody just pointed out in the comments, as one possible use. So you can see for each family that, so this is one. So we have the ID for the row in this table, and we have a farm survey ID number linking them back to this table. So this is a foreign key in our table, and it links back to here where it is the primary ID number. And so, yeah, here are various household members of that household across these rows in this table. But there we have lots of these. So this one is memberships to farmer groups within that household. And of course, they can be a member of many different groups. We have workforce. So this is people that farm is hiring to perform whatever sort of types of activity. It could be planting, it could be working with livestock, it could be domestic chores. And so for each farm, we have this list of workers, and this could be seasonal or permanent workers. We also have a few different tables on the amount, on the various different plots of land that they use. And these are actually split so that we have land that they own, land that they use but don't own, land they've lented out, and land they are currently renting. Even areas not that they own, but they use for grazing their livestock. We have a table on various farming equipment that they own, as well as rented and that they've sold. All the crops, crops they grow in gardens, trees that they grow, animals, fertilizer they use, pesticides that they use, agroecological practices that they do and don't use. It keeps let's go across. Yeah, so here's one that's agroecological practices that they use, and here's a list of agroecological practices that they are not using. It's about credit and remittances. Basically, this is a very extensive survey that has many repeat groups. So this lends itself to creating these many different relational data tables. And in this case, we are exporting this into Excel to kind of show this off. And actually, if I go back to the main one, you'll see an example of how this actually links into a relational database. So this, what you're currently seeing is data that has been exported from a database, but we actually have other data tables within that database that are not currently in this document. So for example, you'll see here that we have a team ID, we have a country ID, a district ID, and a village ID. And these themselves are foreign keys for database tables that are not in this spreadsheet, because they aren't really necessary to data analysis, but through, again, some data linking that would still be doable, that they would be able to get this information out on where exactly this corresponds to. And using those tables is also something we use to help generate our data dictionary for this data. So that's sort of one of our key examples. It's a very extensive example. We do have another one. So this is actually from the same project, but where we've summarized a lot of the information up to this farm level. So if I scroll across, you'll see some information here on some animals. Animals itself was a data table in the previous example. We have sort of summarized that information up to generate these variables about, okay, do they own any goats? Do they own any cattle? So that information was at the lower level, and we bring it up. And that sort of allowed us to trim all that information down into a separate sort of way of storing this data that only has these three data tables. So we have one that's the main survey, one still about the agroecological practices, but both those that they do and don't use, and one about sort of different crop management methods, one to do with soil and fertility, and another to do with pest and disease. So let's think a little bit more about when we might use relational data still. So as I say, whenever you're dealing with any projects that involve data collected that is available at multiple hierarchies, it's highly recommended that you would use relational databases or data sets, because it's certainly much simpler when it comes to certain things such as analysis and even data handling, because if you try as much as you can to keep as much of that data into just the single data set at whichever level you deem is sort of your primary unit of analysis, whether that's the farm or the plot, you really sort of overextend that data set. You could end up easily with a data set that's unnecessarily thousands of columns long, when it is much simpler just to keep these databases table, join up the necessary information when you need it. So don't bother bringing all this data from different levels if really you're not going to use it. And even when you're using these lower levels, you can summarize that information to create new data tables at a higher level, or to create summaries of information that you can then bring up to a high level. So say, for example, if in your farmer data table, you didn't have information on what the average size of all their plots was, you can go to your plot level data table, work out what that average is, and then merge it up with your farmer data so that you have that information now available, and it's stored at the level at which you need it. And similarly, what we said on Monday when we were saying about longitudinal repeated measures data, it's a very similar thing here as well, that you could also consider time points to be a kind of level of your units, which could describe the need to split your data. Some people will have very different ideas on how they want to store data that comes from different time points. Some may prefer that they sort of stack this information all into the one long table, or they kind of want that wide data that we had before of set of columns for time point 1, set of columns for time point 2, but it's all storing the same information. Alternatively, it could be a good idea to use relational data for this same purpose, so that you have individual data sets for the data collected at each time point. So you could have a table for your baseline, a table for your midline, and a table for your end line. And again, because this would be an example where the primary keys would directly link, perhaps because each table is the same unit of analysis, it's the same household, it's just the same household at different time points. So it kind of just would link straight together. So your primary keys might be directly the same. So now we can go on a bit to when it comes to storing relational data. So there are a few possibilities, and this sort of brings up where we were with Shifa and the databases versus Excel workbooks and spreadsheets. So these are certainly two possibilities as well, is that you can have all this information stored in these different tables in a database, and certainly this would probably be the preferred option, but perhaps only if you are comfortable using that type of software. But you also have Excel files, and that's sort of an example that I showed you. Although that data came from a database, we exported it into Excel to share with others, as this is kind of also a simple way to share this sort of large range of information with people at once. And alternatively, you could also just sort of simply have multiple data files, but obviously keep them in a well-managed file structure. So all of these are sensible and possible options. And I think, as I showed on Monday sessions, we also had, if you're using ODK, then Excel files are that easy option, because as we saw, when we export things from ODK into XLS, it has these separate sheets within that Excel workbook, which is where it stores the repeated group data. And generally, one way in which we use repeated groups is for collecting data that is at a lower information, a lower level than sort of our primary focus. So a repeat group that is for information about all the plots, or a repeat group that's about all of the people in that household. If you're using ODK, it neatly generates this information for you. which you may see if you have used this, you'll notice that when you have this, that on that repeated group, it comes with this column that says sort of parent index, and that helps you, that is your foreign key for that repeated group table, because it links back to an index number, which will be present in your main survey sort of table that it produces. So ODK already produces the keys required for a relational data system for you. And so then also databases are of course very useful and especially secure. That's a significant part of using databases. And it also allows you to link the data very quickly. But of course, as I say, this is quite a technical route and not everyone will be comfortable with. I know I'm still not quite there when it comes to my database knowledge and expertise. So many of us will find it simpler to work with many different sheets of an Excel file. But also multiple data files is also a possibility, as this allows you to work only to look at the data level that you require. But of course, remember to keep it well organized so that someone else will be able to follow that structure when approaching your data.